Hi everyone, welcome to my channel EduTech. Today we are going to looking some examples of PN junction diode. Okay, so in that the first question, when a reverse bias is applied to a germanium PN junction diode, the reverse saturation current is at room temperature is 0.3 microamps. Determine the current flowing in the diode when 0.15 volts forward bias is applied at room temperature. So now look at here, we need to find out current flowing in the diode when you apply forward bias voltage. Okay, how much? 0.15 volt. We need to find out current flowing in the diode. Okay, now what are the values as given? Reverse saturation current also is given. What is the value? 0.3 microamps for at room temperature. Now we need to solve the what is the current flowing in this diode. Okay, now solution. First you should write given data. What are the values given in the question? So when you are going for examination, please, when you doing the values of problems, you should write given data first of all. What are the values given in the question and what are you going to find out? That also you should include when you are doing the problem. Then only you will get some, based on this given data, that will be giving some marks. Okay, so when you are doing the problem, they will split up different values, different marks, so that you should write given data, right? So in the given question, reverse saturation current is given, and then germanium. What is the diode which is used? Germanium diode. Okay, then reverse saturation current and applied voltage 0.15 volt. So these are the values you should write first of all. So given data, first one is reverse saturation current. Reverse saturation current. What is the value? I0, that equal to 0.3 microamps. Okay, so this also can be written as 0.3 into 10 to the power of minus 6, because what is the value of micro? 10 to the power of minus 6. Okay, that is amps. Now what is the diode which is used? Germanium PN junction diode. So that is eta equal to 1 for germanium. Germanium diode is eta equal to 1, right? Now what is the given? Forward voltage. That is forward bias voltage. You can write as VF, that equal to 0.15 volt. Okay, so these are the values has given in the given question, right? And what you going to find out? That is forward current diode. Diode current, that is I. You should find out. Now if I want to find out this current value, then what is the equation you should find out? What is the formula? As we know that from the diode current equation, we can write as I equal to I0 into e power Vf by eta Vt minus 1. This is the given equation, right? So from this equation you should find out what are the values given in the given question. So I0 is given, Vf is given, and eta also is given, that is germanium. Now you should find out the value of Vt. As we know already, when you are studying about temperature, dependence on VA characteristics, so you should know Vt equal to Kt by Q. So from this value, with help of K and Q, you will get T by 11,600. So what's the value of temperature T? That is 300 divided by 11,600. So finally Vt equal to 26 millivolts. So this is the value of Vt if you calculate this value, right? So now we got this value, then you should substitute in this equation, diode current equation. So I equal to, what's the value of given? I naught, that is 0.3 into 10 to the power of minus 6 into e power, what's the value of V? That is Vf by eta Vt. Vf is nothing but, that is forward voltage 0.15 divided by, what is the value eta? That is 1 into, what is the value of Vt? 26 into 10 power of minus 3. So minus 1. So this is the exponential value. Okay. So now what's the further? So further simplification. That is I equal to 0.3 into 10 power of minus 6 e power 0.15 into 10 to the power of cube divided by 26 minus 1. So before 26 into 10 to the power of minus 3 is there, right? So that value 10 to the power of minus 3 get into the numerator, that becomes 10 to the power of 3. Now 10 cube by 26. Take the calculator and take this value. 10 power of cube means 1000. 1000 by 26, you will get nearly 38 point something, right? This value should be take nearly 40, approximately 40. So what's the equation becomes? I equal to 0.3 into 10 to the power of minus 6. So e power. So this total value will get as 0.15 into 40 minus 1. Okay. By taking this value 10 power of cube by 26, that is a value of 40. Now we should multiply with 0.15 into 40, that equal to 0.3 into 10 power of minus 6 e power 40. Okay, by multiply this value, this will get e power 6. 0.15 into 40, you will get e power 6 minus 1. Okay, so by taking calculation, you will get finally the value of 1 point. Just a minute, I will take this calculator. So 0.3 into 10 power of minus 6 into e power 6 minus 1. So when you are going to take a calculator, first take this value e power 6. What is the value of getting e power 6? That you have to substitute, then minus 1, then multiply with this value 0.3 into 10 power of minus 6. So totally you will get it 120.73 microamps. So this is the current which is getting diode current. So hope you understand. Thank you.